If you'd like to find out how one of these fuel tank sender units work, we're going to cover that right now in this video. These are typical to what you'd find in many motorcycles, especially the older ones, and sometimes they give a little bit of trouble. So we're going to go over these, explain how they work, how to test them in this video. So let's get right to it. As I said in a quick intro, what we're going to do is we're going to go over one of these fuel tank sender units that's typical to pretty much just about any motorcycle out there, especially the older ones, but you can find them in newer ones as well. It's important to understand how these work in order to evaluate and possibly do some minor repairs on them. You know, I would call this somewhat user serviceable, but it really isn't in regards to like being able to find like parts for it. But most of these you can take at least a cover off and get a good look at the parts inside there and see if there's any corrosion or something and clean it up, and a lot of times that just solves the problem. But let's go ahead and pop this cover off, show you what's in there, kind of give you a brief explanation as to how it works and what the parts do, and then we'll take it from there. Now some of these will have a little clip like this, others will have a little tang that bends over, kind of like, you know, the I don't know if you guys ever had those old Tonka trucks, you know, and you took them apart or something, or even, you know, toys of some sort that have a little metal tang that bends over through a slot. Most of them are like that, actually, not like this. But anyway, so in this case, all I got to do is just kind of pry these apart gently and then pop this off. This is just a cover. And off we go. All right, business end. So really all this is a variable resistor. This is a variable resistor, really. You have a wiper that's connected to one side of the circuit. In this case, you know, it'll be most likely on the ground side here because this is isolated up to the coil. The two sides of the circuit essentially are there for putting a voltage through this, and then when the voltage comes out, it's going to be varying by the fact that this is, again, a variable resistor. So if you look at this from a perspective of how it's oriented in the tank, and I think that's probably one of the most important things you need to do, is that you have to understand that when it's properly oriented or properly clocked, which side is down, in other words empty, and which side would be up in regards to full, because you want to be able to test it and see what the values are in those separate positions. Now in this case, this one actually sits in the tank sideways because it goes in the sub-tank of that Shadow 1100. So it mounts this way, and so this would be empty, and then when it's upright, this would be full. Now on this particular bike, the sub-tank, you know, has a sender, as you can see right here, but most of the time you're going to have them on regular fuel tanks, you know, on regular, you know, 4 or 5 gallon fuel tanks on a motorcycle, and they'll be mounted underneath. And it'll arc, you know, it'll basically arc this way instead, you know, up and down. Either way, it doesn't matter. Just make sure you understand which position you're in, because if you're having a problem at one end or the other, and that's why I mention it, then you got to be able to understand what the values are at each end and through the sweep, and that way you get an idea of whether or not you can repair this by cleaning it, or whether it's trashed or what have you. Now when you're testing this, I don't really believe that the actual resistance values on your meter are all that relevant, because I can't actually find, I've never been able to find any information in a service manual that'll tell you, you know, what the values are, the sweep values as far as one end to the other of this thing. It's not really important, again, because what you really want to do is you want to check to make sure that it's reading and reading smoothly through the range. And so if it gets a little bit, you know, cattywampus on you as far as bouncing around on your meter, then you know you have a bad connection or there's something else going on. It could simply be a bad solder joint. It could be some corrosion. It could be the coil is bad. You know, if it looks all corroded, then that's one thing. You just start cleaning it and retest it. But essentially, you know, you're really just looking to see if the thing is working smoothly throughout the range. You definitely don't need any fancy meter. Put it on the horseshoe setting and you're going to check for resistance. I would recommend, yeah, the auto range of your Meter is fine. And we're just going to hook up these terminals with my homemade clips that don't work half the time. All right, can you see that? Here we go. Okay, so as I said before, this one is set up in the tank just as you see it right now. So with simply gravity, Sir Isaac Newton working in our favor, we have this down in the lowest position. So this would be empty. And right now it's showing, what, 10.5 ohm. I'm sorry, 105 ohms. Is that right? All right, well, whatever. Let's run it through the sweep and see what happens. I'm going to go right to the other end and see what it is. And this is at about 5, let's call it roughly 5 ohms. Let's go up a little bit more. Then we're in the kilo ohm range. Yeah, there's something going on here. So if we bring it up through the range, down here, that seems about more likely to be the case, you know, where it's supposed to be a 2.4 ohms. It shouldn't be that high ohmage down the other end. So as you can see, we're about halfway now. We're at 34.4, 36 ohms, something like that. And we drop down a little bit further, 40. That's about right. You know, it's changing where you'd expect it to be. Up here, it's very, you know, low resistance, 4 ohms. And then we start going higher and higher as we go down the range. Now let's go to the end here again. And you see it's I don't know. It might be right. But again, it's not too terribly important what the numbers are. That kilo ohm reading we just got was probably an anomaly because it couldn't quite, you know, as you're moving it, there's a resistance variable in that movement itself. So, you know, I'm not going to hold that to any particular address as far as, you know, the numbers go. All right, so I guess we're going to call this, at one end we got about 105 ohms, and that would be low, so high resistance. Or higher, and then as we move it up where the fuel level would be rising, the resistance level drops, and it seems to be dropping pretty smoothly and not jumping around too much, so that's not too bad. Yeah. All right, so if you did have that situation where the meter was just all over the place and you couldn't quite, even when you had it sitting, you know, firmly, see right there, it's a bad spot. There's no way it's supposed to be 1.58 kilo ohms there. So we just move it a little bit. Now we're down to 47, 48. So it's just a particular spot on it, and we move it a little further and we're back down. You see how that works? And I'm not going to worry about that too much because this is going to be moving around anyway, you know, as the motorcycle moves. And I guess how they work it is, you know, the way the meter interprets the you know, the voltage value change coming to it, it kind of has some sort of a smoothing effect in there. I don't know how that works, but you know, if you have a little bit of a change like that in one, or I should say a spot in one area, a very small area, you know, I'm not going to worry about it too much. So let's say it was going really wacko on you. What would you do about it? All right, so there's essentially two reasons why you'd have some funky readings going on, and they are both related to the contact of this wiper right here, the thing that swings back and forth, and the actual coil, if you will, that it rubs against. One would simply be just some corrosion or some you know, some oxidation or something in there, and the other one would be actual contact of this wiper against the coil. As far as the corrosion goes, it's pretty easy to solve. Essentially all you do is you take some very fine sandpaper and just wiggle it up in here, and usually you can just wiggle it around and get this thing pretty clean, and then clean it off with some solvent, like just a dab of some alcohol really works good in this application. And then you can just lightly touch these as well. You really don't want to go too aggressive on the coil side. In fact, I'd stay away from abrasives on that if you can. Just wipe it down with some alcohol and then try it again. You should have a little bit of drag on this, you know, you can feel it. It should be dragging, and if there's no drag, then that's probably a telltale sign of the second issue, which would be contact to this wiper. Now that's a little more difficult to solve. You know, over time, maybe bouncing around this thing inside a tank, this thing may get a little bit weaker, and it's kind of a springy metal that pushes against the actual coil. You can kind of see that angle of the dangle. Plus, there's a little spring back here, and the way this is engineered, it just keeps that pressure against this coil. That's a little more difficult to solve because you really have to kind of bend this tab in, and the only way to do that is really to remove it. There's two reasons why you'd remove it. That's one of the reasons. The other reason is to actually correct some inaccurate readings of the fuel level by clocking this in a different location if it's actually clockable. It depends on, different one. I haven't actually seen one with a square nut like this, so I'm not 100% sure on this one, but we'll cover that briefly in a second. So what you'd have to do is you'd have to very carefully, I'm not going to do this one because I think it's reading fine, is to undo that whatever is capturing it, a little nut or something. And it's a little floaty in there. It is on a spring, so it's on this. It's locked into this fastener or the spring this way, and then it just kind of rides in there with that pressure and keeps it down in there. But this particular one is, let's see if we can see that a little bit better. Yeah, I'm not 100% sure on how this one works without taking it apart. It's a little different from the ones I've seen in the past. It almost looks like the wiper is part of the nut. I think that's what it is. Or, I don't know, maybe just be stuck there. I wouldn't think it is, but anyway, doesn't matter. If it's not making enough contact, you're gonna have to bend it in. And again, probably the only and best way to do that is to take this off and take a couple pictures of it if you need to maintain the orientation of everything when you put it back together, and then bend it and put it back together. And then what I do in that case is I'll set this to one side or the other, and so when it's bumped up against this end or bumped up against that end, where is this wiper exactly pointing at that point? Make a little mark, that way I can reclock it in that location, and you tighten the nut down or however that's fastened. Like I said, I haven't seen one like this, so I'm not going to mess with it. But so yeah, that's really all you got to do in this is just clock it around to or bend it rather, to get a little bit more contact, then retest it, and it'll probably solve it. Now, as far as adjusting this, I don't necessarily recommend you do that because it's really trial and error, and it takes a while. But if you have a fuel level that's like really far off, like for example, if you've got a half a tank of fuel and it's reading empty, then when you take this out and test it, and it tests good as far as the sweep goes and resistance readings, then something's off as far as the alignment of this float to the wiper. So really you have to adjust that. There's two ways you can adjust that. You can do it the way I said before by reclocking this, if that's possible. The other way is simply bending this arm. This one is a little thicker than the ones I've seen, and it's also shorter because it's a smaller tank it goes in. But the ones that sit in the gas tanks like this, that are for the 4 or 5 gallon gas tanks, are usually a lot longer, and so they're a lot easier to bend. So you can actually manipulate the angle of the dangle, so to speak, of those by just bending that arm in the direction that you want to bend it in. And that can be a little confusing. It's kind of like the float levels in carburetors, especially if you're looking at the carb upside down, that you want to raise a fuel level versus lower a fuel level. You have to bend the tang on the float, kind of opposite of what you think it would be to achieve the results you want. Well, this is kind of similar to that. So I'll try to explain that. Now, we're going to put this in the position that it's oriented. Again, this is where it's mounted with those tangs up. We'll just flip it around to this side. So this is how it lives if you're looking at it from inside the tank. So if you live inside that gas tank and you look up at the fuel sender, this is what you're seeing, okay, in that orientation. So with that in mind, let's say you do have a half a tank of fuel, this thing really should be sitting about right there, okay? So it should be sitting about halfway along that sweep, or roughly, plus or minus, depending on how, the engineers laid out the number of windings in that coil. So if it's reading completely empty, it thinks it's down here. So there's a good possibility that this relationship of the float to the wiper is actually when this thing is sitting here, the wiper is actually there. So what you have to do is you have to adjust that or bend the arm to compensate for that. So if we're going to use that same example, we have a half a tank of fuel and it's reading empty. When we are in this position, which is about half a tank it looks like, and that wiper is too far up to this end, and we know that that's the low side, of course, because there's low and there's high, then we want to hold the arm in the position that we think that's going to be half a tank. But manipulate the wiper in the manner I described before by loosening the nut and moving this wiper, clocking it, and then tighten it back down. And that is a pain in the butt, I'll tell you right now, because it's all trial and error. You have to basically do it and test it, put gas back in the tank, take gas out of the tank. You know, it's kind of a pain in the ass. So I don't recommend doing it unless the thing is really, really far off. But you can do it. I have reset these. I have bent the arms to compensate. And of course, I have taken them apart and bent these wiper tangs so they hit that coil a little harder. It can be done, all right? You just have to, again, hold it in the position that it's normally mounted. Normally mounted in, and then calculate essentially where it's supposed to be in relationship to how you're reading it, like with a half a tank, as I said before, and then say, well, if it's reading too far up this way, then I simply need to hold this and then move the wiper in that direction. So this is high and that's low. So you get the gist of it. You just have to look at the one you got, and then you can make the adjustments accordingly for it. I'll go ahead and show you another one that's like this with the actual wiper, and instead of a coil, this one uses some sort of there's like a little printed circuit board. I got another one I can kind of show you that is, this is a replacement fuel pump for that 2003 Bergman. I just finished this up yesterday. This is an eBay buy. Took it all apart, cleaned up the motor and the corrosion, and then put a new fuel pump in and put brand new immersible or submersible fuel line in between the two of them. And that crap is expensive. 1 foot of submersible fuel line like this is $36 at Pep Boys. So that, what does that calculate? I figured that out. It's like $3 an inch that I have to charge a customer. Anyway, this is what the inside of that looks like. The reason why you're able to see it rather is because that outside area, that would be this part, is completely corroded away and missing because this thing's been sitting for I don't know how many centuries. But you can see it's got a little different setup. It's got some sort of a little, it looks like a PC board, but it must have a variety of resistors inside there or something that when it comes across the sweep here, it hits a certain area of it that provides a different level of resistance based on that particular location. I don't know how it works, but I don't know. But we could take it apart and look, but I'm not going to worry about it right now. And so if you were dealing with something like this, and of course this is newer. This is from an 03, and the one that I showed you before was from that 85. But again, the testing is the same way. On this one, all you got to do is kind of trace the wires up, and they change color, of course. But here's the two wires off of the actual sender. One's brown and one's black. They go up to this side of this plug. And then they change colors out here. But it don't matter because all we have to do is find the two that are to the, let's see, which ones are those again? They are, brown and black on the bottom. And what they do is they turn into gray and, they turn into gray and green because it's on this side of the connector. So all I do is I hook the meter up to that, but I have to do it in this tiny little plug, which is not fun. And we can basically do the same thing we did on the other one. We can swing it and see that it changes value. And so pretty much it's right up the top. This would be where it's at full, and then this would be where it's at empty. That goes through the range pretty nice. That's obviously, I think, a better sender type than the one that I showed you before. But yeah, pretty nice. Yeah, I like it a lot. I like it a lot. So that's how you test that. You can test any of them to see if they're actually working. Again, the values that you read at one end, the middle, or the top end, whatever you want to talk about as far as ends go, full, empty, what have you, don't matter because you're not going to find those anyway. Unless you happen to be related to or know the engineer that built these things or designed them, then yeah, then you'll know it. But otherwise, it doesn't really matter. What matters is that you get a a sweep across the range that's even and constant and seems about right. Because really, it is what it is. Besides bending, in this particular one, you're not going to be able to clock that. So you'd have to bend the arm, but I'm not going to mess with it because we're going to leave it the way it is. But anyway, so that's just another example. You can even test, more modern ones the same exact way and see that they're most likely working. I mean, you have a high confidence that this is a perfectly or normal functioning fuel level sender. I'll show you another one that's kind of interesting from my Magna. It's actually a low fuel sensor. There is no fuel gauge on some motorcycles, so some of them just have a low fuel sensor. And the Magna, the 82 Magna that I have, does not have a reserve setting on the tank, any of the tank. Remember, I told you before it has a sub tank just like the Shadow does. So it has the main tank up top side, and it has the the sub tank down in the frame just like the Shadow does. So this is located in the sub-tank of the Magna. It's mounted from the top. And what this is called is a thermistor. It's a thermal resistor. And this is just a spare one I had laying around because I replaced the tank on that because it was so bad originally. And when I bought a replacement tank, it had one of these in it. And these are actually serviceable. I found the information on a forum somewhere. I don't remember the exact value, but I was able to obtain 2 of the thermal resistors or thermistors and online, like from electronics place. And then you can actually disassemble these. I forgot exactly how you do it, but you end up desoldering the end here and desoldering the wire. Then you pop this out of this little case. And I remember it's very precarious, I guess would be the word. Because you kind of make sure that nothing's touching ground. It has to go from one end of that to the actual wire and out. That's why this plastic insulator is there, I guess. So how this works is it's immersed in fuel. Let's say it's immersed in fuel in that tank, that sub-tank. That sub-tank is fed by the main tank. So essentially, if the main tank has gas in it, the sub-tank is full all the time, okay? So this thing is down in the fuel, and it's at a certain temperature based on the temperature of the fuel, and of course that varies a little bit based on atmospheric temperature or whatever the temperature is from heat radiating back from the engine or what have you. But it's not enough to really affect this, and it sits at a temperature and leaves the light off because of the voltage going through it, and then the voltage coming out is, I don't know what it is, but it's at a certain voltage that doesn't turn that little light on, and there's a primitive little module in there that monitors this. So then the fuel level goes down because the main tank is out of fuel, and you burn it off down to a certain point in the sub-tank, and then all of a sudden this thing starts to change temperature. Obviously it's going to warm up some, and then the resistance either goes up or down, I don't know. And then the value coming out of voltage going in, voltage going out is different. That little module reacts to that, and it starts to turn the low fuel light on. It'll actually glow first, and then it gets pretty bright as this thing gets out of fuel. Because the fuel is splashing around, and it kind of gets it back to normal operating temperature. But once it gets down low enough, and it's out of fuel long enough, that light burns pretty bright. So that's just an interesting way that they do it, just another fuel level sensor that, yeah, you can service them. If I could find that information, I'd probably go order some more and just put this together. It'd be an interesting video probably. But I don't know. I thought I had another one of those damn things, but I can't find it. So, the thermal resistors. But who knows what happens to crap around here. All right, so that about covers that. I hope that wasn't too terribly confusing on the adjusting this thing by bending that rod. Like I said, I've done it both ways. The other things you want to make sure on these things is the terminals are really good and clean wherever the wires go to them. Make sure all the wiring on the bike side where these terminals go in is good as well. But if you've determined that everything upstream essentially from your sensor is good, then it's the sensor, and these are pretty common to get a little bit corroded up over the years. Do not forget to put the cover back on it before you install it in the tank. Don't ask me how I know. I did it once and only once. So that's a real pain in the ass. So you want to snap this back on or put it through and then bend the little tabs over if you have that kind. So All right, hope you liked it. I hope it helped somebody. I hope you got something out of it. If you'd like to subscribe to the channel, I'd sure appreciate that. That way you get notified in some way, shape, or form when I put new videos up. If you want to definitively do that, ring the bell on the channel, and that will definitely tell you when I put a new video up. If you like the video, then please click the like, because then it helps the analytics on the channel, and then it gets more views, and everybody can benefit from that. So I guess at this point we'll sign off by saying, don't just repair, restore. Catch you on the next video.